session. Every day, we come across a wide variety of information in the form of facts, numerical figures, tables, graphs, etc. These are provided by newspapers, televisions, magazines, and other means of communication. These may relate to cricket batting or bowling averages, profits of a company, temperatures of cities, expenditures in various sectors of a 5-year plan, polling results, and so on. These facts or figures, which are numerical or otherwise collected with a definite purpose, are called data. Data is a plural form of the Latin word datum. Of course, the word data is not new for you. You have studied about data and data handling in earlier classes. This data can be expressed in different forms as charts, diagrams, graphs, etc. so that the data is easily accessible. Today, we will be learning 3 such diagrams, or as you can say, 3 ways of expressing data. Let us first study about the histogram. Let us consider the marks obtained by 60 students in mathematics test. The table shows number of students who score marks 0 to 10, 10 to 20, 30 to 40, etc. in the test. Data presented in this manner is said to be grouped, and the distribution obtained is called grouped frequency distribution. It helps us to draw meaningful inferences like most of the students have scored between 20 and 30. Only one student scored between 50 and 60. Each of the groups 0 to 10, 10 to 20, 20 to 30, etc. is called a class interval. Observe that 10 occurs in both the classes, that is 0 to 10 as well as 10 to 20. Similarly, 20 occur in classes 10 to 20 and 20 to 30. But it is not possible that an observation, say 10 or 20, can belong simultaneously to 2 classes. To avoid this, we adopt the convention that the common observation will belong to the higher class, that is 10 belongs to the class interval 10 to 20 and not to 0 to 10. Similarly, 20 belongs to 20 to 30 and not to 10 to 20. Such groups are called continuous groups. In the class interval 10 to 20, 10 is called the lower class limit and 20 is called the upper class limit. Similarly, in the class interval 20 to 30, 20 is a lower class limit and 30 is the upper class limit. Observe that the difference between the upper class limit and the lower class limit for each of the class intervals 0 to 10, 10 to 20, 20 to 30 and so on is equal. The difference between the upper class limit and the lower class limit is called the width or size of the class interval. The number of students who get marks within that range gives the number of students in that group. For example, look at the interval 0 to 10. The number of students who got marks between 0 and 10 is 2. Now 2 is called the frequency of the interval 0 to 10. Frequency gives the number of times that a particular entry occurs. The table made is known as frequency distribution table, as it gives the number of times an entry occurs. This particular frequency distribution table is a continuous frequency distribution table as the intervals are continuous. Now this is displayed graphically as in the adjoining graph. The height of the bars show the frequency of the class interval. Also, there is no gap between the bars as there is no gap between the class intervals. The graphical representation of data in this manner is called a histogram. The histogram is a two-dimensional graphical representation of continuous frequency distribution. In this type of graph, rectangles are drawn with bases proportional to class intervals and heights proportional to the frequencies of the respective classes. The example we just showed was for continuous group data. Let us now see how to draw a histogram. Like any other mathematical problem, we need to follow a few steps to draw a histogram. When the data is given to us, we first check if it is continuous. Next, we choose suitable scales to mark the class interval on the x-axis and frequencies on the y-axis. Students, please do keep in mind that the scales for the x-axis and y-axis need not be the same. For example, on the x-axis, 1 centimeter might be equal to 10 units, while on the y-axis, 1 centimeter might be equal to 20 units. Once you have chosen suitable scales, construct the rectangles with the class intervals as the basis and the corresponding frequencies as the heights. Let's look at this frequency distribution table and construct a histogram. We choose scales as 1 centimeter is equal to 8 units on the x-axis and 1 centimeter is equal to 2 units on the y-axis. Thus, starting at 0, we mark 8, 16, 24, 32 and 40 at equal distances on the x-axis and 2, 4, 6, 8, 10 and 12 at equal distances on the y-axis. We label the x-axis as class intervals and the y-axis as frequency. Now let's proceed to draw the histogram. Starting with the first interval 0 to 8 on the x-axis, we mark the frequency of the interval, that is 6 on the y-axis, and draw the rectangle with base 0 to 8 and height 6. Similarly, we take the interval 8, 16 and mark its frequency, that is 9 on the y-axis, and draw the rectangle with base 8 to 16 and height 9. Next, we mark 12 for the interval 16 to 24 and draw the rectangle. For the interval 24 to 32, we mark its frequency 10 on the y-axis and draw the rectangle. And finally, for the interval 32 to 40, we mark the frequency, that is 5 on the y-axis and draw the rectangle with base 32 to 40 and height 5. The resulting graph that we get is called a histogram.